Okay, did folks get my welcome email? Did that link not work? Or you just all hate me?
Yeah.
You guys didn't get a welcome email? Did I send it twice to the same class? Oh shit. All right, well, okay. I'll post this later. It's a welcoming, just to be like, what do you guys know? No? That's weird. All right, I'm not gonna try and track that down right now. Why is it not right at the top? Why is it dark? Okay. Hello. Hopefully you're all here for this class. Okay. Did I do what I wanted to do? You're gonna ignore that, right? Oh, I was gonna hold that against. Hi, I'm Paswani, so I am the instructor for this class. I know some of you, but not all of you. So I'll introduce myself first, and then we'll go around to your name, pronouns, what year you're in, what your focus is, and then like take away from the class. So this is my fourth and a half year. 5 years by the time that I finish May at CSUSB. Started in the pandemic. Not great. It's been good for a long time. And then there's all these fires in my house. So currently I am not living. And I have the same jeans. So no comments on my wardrobe until I get my wardrobe back. I did my undergrad at Santa Cruz in physics and astrophysics. And then I went to Boulder, where I got my PhD in planetary science, and I study the Martian atmosphere. So we use a number of different spacecraft to understand how the atmosphere on Mars has evolved and what it's doing today. And surprisingly, you think, well, what does that have to do with fluid dynamics? Turns out that atmospheres are fluids. So we'll get into that concept basically today. How do we think about concept fluids and concept? He, him. You can call me Dr. Grismani. Call me you. You can call me Mateo if you want. Some people I know, they're like, I don't care. Okay. Pretty much. Yeah.
That is my name. Hello. I'm a physics major with a master's in biophysics.
Okay.
And then a PhD in physics, but like research in biophysics. But if that does not work out, then hit that as down market.
Yeah, that's right. Yeah. Cool. And so what do you want to get out of this?
I wanted to learn more about how to model fluids and whatnot, and like the math that we need.
Cool.
So awesome. Yeah, thank you.
For pronoun?
He, him.
He, him, and Brandon's good?
Yes.
Name, preferred pronouns, year, and what you want to get out of it.
She, her, what else did you say?
Year?
Year, last year.
Last year?
Yeah.
Okay, last semester. Senioritis?
Huh.
Let's go. Okay, what do you want to get out of the class?
Well, I'm an astro as well. So it'd be great for learning a lot of stuff for fluids.
Cool. Next.
My name is Brandon. Oh, shit, oh no, I didn't hear.
Got it. Got it, a third of the class.
Then I just helped the class.
Cool. And what year are you?
I'm sorry,
What year?
third year?
Okay, so you have one more to go. Okay, do you have, what's your last name?
Jimenez?
Jimenez? Okay, so, okay. So Brandon S, Brandon J. I'll try to remember that. I know 6 names is a lot to remember, but I'll try.
My name is Elliot. I'm a third year physics major, hoping to get into masters in physics, continue research, hopefully, with a focus on aerospace.
Okay.
So hopefully,
Yeah.
so
That's good.
yeah, so
Cool.
that's that kind of wraps up my interest for the class for sure.
Awesome.
Hi, I'm Trinity. They did the second one last year. She,
Last semester?
no.
Oh.
Last year, I was fall, graduate. I'm just here to extra elected. I thought the aerospace was interesting too, so.
Okay, cool.
My name is Bethany. This is my last year, so I will graduate in the fall.
Same.
Yeah, my pronouns are she, hers, and then I also want to get into like aerospace engineering, so there's a lot of applications for that.
Okay, cool. Well, I love fluids, so I hope that I will not make you hate fluids. It is an upper division elective, so it's not a cakewalk. But hopefully the team that you see here will be instrumental in helping you like really understand a lot of these very complicated concepts and maybe working with one another, working with me. You'll feel like, oh shit, I actually understand something that is very non-intuitive, right? Three of you have taken class with me before, right? We had computational, but you're taking computational now? Okay. Okay. We're gonna go over like how I like to run classes. And then we can decide whether we want to jump into material or whether you want to take a pop quiz. No? Okay, raise your hand if you want a pop quiz. It's not graded, but you do have to do it. No, like you have to do it. So like before next class, before Monday. It's one page double-sided.
Oh, so you're saying we have to turn it?
We have to turn it in eventually.
You have to turn it in eventually. Turn it now? Okay. All right. So let's talk first about the structure of the class and then we'll do the concept of inventory. What's this? Water. Okay. Can you recognize water? How do you know it's water and not something else? It's clear. Good. Okay. What else do you see? Droplets. Interesting. Okay. Anything else?
I guess.
Waves. Ooh, I like that. Anything else? What fluid concepts can you like see? They don't have to be exactly the right words, but like stuff that you just, what is jumping out to you? I heard clear, heard droplets.
Was it viscosity? It's like showing it's not too strong, right?
Yeah. So there's something about like how it's moving, right? You can definitely tell this is not a solid. Or maybe it is, it's not in motion. Right? Could this be glass? It could be, right? Could it be rock? No, very unlikely that this is rock, right? Unless someone's a really good sculptor, right? Could this be gas? Could it? Yeah. Okay. This should work. Oh, I have to plug it in. There's no technical difficulties. It's not my class. Okay. Oh shit! I didn't bring the book. All right. That's my book. Okay. So come on now. This is the book This is the 4th edition. This is what I learned on many years ago. You're welcome to get the 5th edition, or the 6th edition, or the 3rd edition. I don't give a shit. Some of them will be more expensive. Some of them will be less expensive. If you want the version that has like all the coolest goodies, that's the most updated edition, right? It's gonna have better rewrites, it's gonna have better problems, and in particular, if you care about the computational aspect, it'll have more of a computational focus. This one is perfectly good. And the nice thing about it, I don't know if I left any notes in here. Well, but the nice thing about a written one is you can write in it. I don't know if you guys are writers. Okay. So that's the first thing you'll need. This one is the most important one. Motivation to learn, right? Especially in an upper division class, it's very easy to feel like, oh, I'll just take a back seat and I'll just come to lecture. And it's only 2 lectures a week for 2 hours. And so I'll just get it done. I can guarantee you, if you only learn in class, you will not do well. And the reason for that is I can only speak at a certain rate without you, 1, falling asleep, and 2, without you getting really frustrated at me, right? I have to take steps, I have to make sure that like we are having a conversation and I'm not just screaming at you very quickly, okay? So part of that will be reading the book beforehand, or reading the book after, or coming to office hours, or doing student help sessions, right? Like that type of thing. We're going to talk about this because you're going to be introduced to my style of grading, which is unlike other styles of grading, which puts the emphasis on doing the problems on you. Okay, so in this way, because this is a class that doesn't require anything after it, not a prerequisite. I'm allowed to do basically whatever I want. I'm always allowed to do whatever I want, but I'm even more allowed to do it here. And so one of the things that I've found successful in the upper division classes is that homeworks are not graded in the traditional sense, and understanding that life happens, life comes at you fast. Sometimes you don't get it in on time, right? But there needs to be accountability. So what I mean by that is you say to me, hey, I'm not getting it in, but it'll be in by Tuesday, right? So you tell me ahead of time, not after it's due, when the homeworks don't come, right? And I can make accommodations for that. You need to be able to communicate. You need to be able to communicate with me, tell me what's going on, and most importantly, tell me what you don't like so that I can fix it. I can't fix what I don't know to fix, right? But also about things that you're not getting. And this is a really key part to becoming a good physicist, right? You want to know what you don't know. It's not enough to know what you know. You have to be able to communicate, hey, I don't think I really understood that as well as I would have wanted to, right? Because that's the way that I can help you become better. Communicate with the people around you. And I'm going to force you guys to be friendly. Okay, so we have 2 new additions. So we're going to introduce the 2 new additions. We're going to say our names, our preferred pronouns, our year, and what we hope to get out of the class.
Kevin, Ethan, our year, I don't know,
You don't know your year? When do you graduate?
in the fall.
In this fall.
Yeah.
So same. Okay,
What I hope to get out of it. Honestly, I don't know.
cool. Okay. We can find out one.
Hi, my name is Daniel. He, him. I also graduated in the fall. So I guess that makes us like seniors or super seniors. What I want to get from this class, I think fluid dynamics is you can apply it everywhere. So, I mean, just understand the world better.
Okay, good. Love that. See if this works. Okay, so this is how we're going to do on grading, and there's a policy that you'll find on Canvas. Zori, you said that the Canvas wasn't published, but I think it is now published. So anything that I talk about or post, it'll go on there. And that includes the lecture slides, the slides that get updated. I have all of them there right now from the last time I taught this a couple of years ago. And what I'll do is every time that we teach a class, I'll just replace it with the actual slide. Okay, I'm not gonna return homework with a number on it. I'm gonna return it with detailed feedback. Okay, so if you don't do a problem, I'm just gonna hand it back to you. Right? It's good for me to see that you're not on track, right? And then I can kind of adjust my expectations. I just tried this, so we did homeworks every other week. It didn't go very well. So we're gonna try and do homeworks every week, even if they're smaller homeworks, just so that you feel some accountability of like getting it in, right? Because sometimes when it gets to 2 weeks, you're like, oh, I forgot. You don't start until like 3 days beforehand or the night beforehand. So we're gonna try and stay on track, okay? You're gonna be holding yourself accountable and learning the material. You may or may not already know this, but that is already your job, right? It's not my money you're spending, I think. Nope. So your education, of course, you get out of it what you put into it. So if you decide that you really only need a C and you're perfectly fine with that, I have no problem with that as an educational goal. If you need an A and you really want to do well, you're gonna have to hold yourself to a higher standard, okay? I am not affected by your grades, but I want you to achieve whatever it is you want to achieve, right? Okay. We're gonna have this sort of conversation a couple times this semester. We'll talk about that as our check-in and just see what's going on. And then if you don't take this seriously or if you undercommit, you won't do as well as you, right? This is very different than recognizing that life comes at you fast, right? So sometimes you give all that you have available. And it may not be what you would want in the ideal circumstance, but it doesn't mean you didn't give all that you have, right? And that's very different than saying, I really just didn't care that much and I had the time, but I just didn't use it well, right? Those are two different grades. Makes sense? Okay. Let's go. How many people have computers or computers open? How many people keep notes with computers? Just 3, 4, 3? 4? Would you prefer to do this type of thing? And normally I have, last time I taught this, we were in the other room and so everyone had a computer in front of them. And I thought this was fun because then multiple people don't have to take the same notes. So you can like find your friend, maybe one person takes notes for the day or like comments on them, and it's sort of a living document that multiple people can work in. And as you go through, you see some new concept, you have a little conversation in the comments. Who like this idea? Raise your hand if you like this idea. 1. No, everyone wants personal notes. So the reason for this is your personal notes never get seen by anyone, right? And so it's difficult for me to know how well you're doing in the class. And in particular, if there's a common misconception, I can see it on everyone's progress reports. So if we keep public notes that as you're writing, let's say you like star something and you're like, Dr. Krismani, is this what you meant? You can write that in class. And then at the end of class, I can go into your document and give some clarification.
We just be published in our notes.
Yeah. I mean, it doesn't have to be to everyone else if people don't want to share their notes. You also don't have to subscribe to this. The reason I do this is because it is very easy to just sit back and look at pretty pictures of fluids all day. And then all of a sudden you're hit with math and you're rocked. You're like, what the fuck is happening? And then you fall asleep and you hate what's going on. If there's accountability in the way that we do our notes and the way that we're engaging with the material, in particular, not just learning in class, right? You take notes, maybe you're reading your book, you're writing the progress report, like, oh, I didn't get this thing, but then I read the book and I got it, right? Then I can see that type of learning, right? My goal is not to see whether or not you passed the quiz. My goal is to determine whether or not you learned. That make sense? Okay. So we're not do these today, but I do think these are really helpful. If everyone hates them, we don't have to do them. If you try them out, you're like, oh, that's kind of interesting. Good. Okay. That's the same thing. What did I say? Okay, I wrote them in the wrong way. Progress reports, this is like your the way that we will do check-ins. So let me remove what I said here. You're going to have other documents that are demonstrating your understanding. The lecture notes is what I would like you to share. Any number of students can use the same document. I think it's smart to have one document. Which is like, think about it, if all 8 of you are taking exactly the same notes, what does that mean? And then for some people, they need the notes in order to be able to like be present in class, right? But if you have a shared document and you have one person who maybe isn't getting a certain section, the other person can go in and say, oh, I remember what you were saying there. Or if you're taking them at the same time, you just jump in. So it's a choice. No, there will be 8+ homeworks. I think there are 16 weeks. I'm going to try and get us to like 10 or 15 weeks of homeworks. See, there will be no exams. Pretty nice, huh? Now not so bad class. But there'll be 3 times in the semester. You're going to reserve a meeting with me. We're going to talk about your progress in the class. Unless you hate that. If you hate that, you can take a test if you want. I always offer that as an opportunity. Some people take me up on it. Some people are really like, I don't want to sit down and feel like I'm being quizzed by you. I'm like, all right, that's fair. But if you don't do either of these things, we can't pass the class, right? Because that's the primary way that I assess your grade. Okay. And you're going to make an argument for how well you're doing in the grade. At the end of this 5 to 10 minutes, we'll talk about all the things that I think go into your grade. You'll assess yourself. I'll tell you where you're under assessing yourself or where you're over assessing yourself. Okay. You used this before? Don't lie to me. Everyone's seen this. What is this? Good, that's the word. What is it? It's AI, is it? No. What is AI? Artificial intelligence. Is this intelligent? No. This is a large language model. Okay. So what this does is it predicts the most likely outcome of your query. What does that mean? Have you ever used text and it has like the next word that it's going to fill in? Predictive text. That is the simplest version of a language model. It looks at the structure of the sentence you've created and finishes the sentence for you. A large language model uses a lot of information about what is the most likely answer to your question. It is not able to think or to reason. So, for example, I ask it the question, the gas giants in our solar system, rank them from least to most dense. Okay, this is something you can find in a book. So here's the activity. The gas giants in the solar system in order of increasing density are Saturn, Jupiter, Uranus, and Neptune. Okay, and you say to yourself, that sounds like a very good list, right? Let's look at their explanation. Okay, this is 0.687. Good. And we want to go from least to most. So that seems like it's good. So this is 1.32. So that's bigger. That's 1.27. Did it do the task? No. Did it appear to do the task well? Okay. This one, it got it in the right place, but it needs to switch things. Now, what you can do is you can complain. And you can tell it that it did a bad job, and it'll switch them. Why did it do that? It didn't learn. It was corrected as to what the most likely answer is. So now, the next time you do it, you might get this, or you might get them flipped. But it does not know the truth. So treat ChatGPT as a very untrustworthy friend. Okay? Someone who's in the class with you, who sounds like an expert, but is sometimes full of shit. Okay. And that's the safest way to use. You can, certainly one of the things that's really cool about this is you can have it explain things in like a specific type of like tone or specific grade level. So like you can, for example, go into your computer, like give me a recipe for bagels, but in haiku form. Right? And it'll go through and like give you a recipe in haiku form. It'll listen to exactly what you're saying. So you can also say something like, all right, tell me what a fluid is at an undergraduate level. And it'll explain that concept to you. And you can even change it. You can be like, explain it even simpler at a 5th grade level, right? Or you can make it even harder, explain it as a graduate student, right? And you can see how changing the input can change its explanation. So if you don't quite understand something, this is a very good travel study buddy, right? But it's not a substitution for your own work. When you present the output, can't present what you get as your own without putting it into your brain hole first. Copy and paste is still illegal. Okay. Beginning of your book, there is a very helpful lexicon of all of them. Beginning this book, the other one. Well, I will post it then, if it's not in every book. Symbols matter, right? They're representations of words, and words are important, right? So if you don't understand the words, you won't understand physics, right? So the idea of the difference between like energy and force, sometimes when we're just talking, we use those interchangeably, but of course in physics, those have specific meanings, right? So I will always start, once we get into doing the fluid actual equations, I have a huge focus on the language. I really want you not to think about this in terms of an engineer, where all we have to do is write the equations and then we understand it. I want you to have an intuitive feeling for the mathematics. And that requires very specific use of language. So if I say, hey, that's not quite the right word, don't take it as me saying, hey, you're a fucking idiot, right? What am I saying? I'm trying to give you just a small correction because we want to be talking all the same way, that we have the same language so we can understand what we're trying to say, right? Okay. So I know more than you, right? That's why I'm up here and you're down there, right? That doesn't mean that when you use a word wrong, that I think less of you. Okay? It's really, really important for you to feel like you're comfortable here. If you say the wrong thing, that's totally okay. We're going to work together to improve the vocabulary. So just imagine that we're speaking 2 different languages. I've been speaking it a little bit longer, and I'm going to coach you on how to speak it just as well as me. Is that fair? Okay. And then there's similar symbols. And that's just because there's not enough Greek letters. Right? So we're going to run out of Greek letters, and you're going to be like, wait, wasn't that sigma this thing like earlier? And I'll be like, yeah, I'm sorry. Like, they didn't figure out how to fix that. Okay. So if there's any sort of discrepancy, you're going to tell me. You're like, wait, wasn't that momentum earlier? That's a perfectly okay question. Right? Is there such thing as a dumb question? What's the dumb question? The one you don't ask, and then it keeps you from understanding. Okay, cool. We're almost there. You have a question about the class? Is it in the syllabus? Is it in the ungrading policy? If you find it there, great. If not, you can send it to me by email. Many of you have Slack. Some of you have arms. You can raise them. I already asked. I was getting ahead of myself. Okay. So that's great. So we have exactly, wait, that's definitely the wrong time, right? Is that moving? Is it just twitching? That's freaky. I don't like that at all. Okay. So I said there are no exams. And of course, the first thing I would do is to lie, right? That's always a great way to build trust. So I have something that's not an exam. This is a concept inventory. I'm gonna give these to you. And you can decide, does everyone have paper? Something to write with? Okay. This is not a test. I said it was a pop quiz, I'm alive. The idea here is I want to know what you know and how well you know it. Because I need to base the class off of where you are, as opposed to just assuming that you all have exactly the same life and background, right? So in that way, what I would like for you to do is answer as many of the questions as you can. Okay? And don't ask for help unless it's like a clarifying question. If you don't know something, just write DK, don't know, instead of leaving it blank. Okay? Some of the things, they're gonna look obvious, some of the things are not. Try not to write on the paper, you won't have nearly enough room. And you need to put your name. Okay. Cool, I love it. Yeah. Well, it's not X. Right. Okay. Yeah. Yeah, it's open to interpretation. Remember, there's no points here, you don't get like credit, so, yeah.
So here's one paper, right?
Yeah. If you want, some people have decided not to. Want 5 minutes for answer time, or do we wanna? How you guys feeling? Folks who aren't done,
Almost done.
almost done? Yeah. That doesn't be perfect, thank you. The fundamental theorem of calculus.
Is it integration or is it derivatives? Cause that's what I put.
The fundamental theorem of calculus is that integration and differentiation are inverse functions of one another. What's a derivative? Okay, rate of change, that is one way of thinking of it, yeah. Is there a mathematical way of proving the derivative? What is that?
The limit
It's a limit, very good, of. Should I bring the chart?
function.
Limit, I think it's the limit of h approaches, 0 and, f of x plus h minus f of x.
F of x
F of x
plus h.
minus f of x divided by h.
Fact. That is the definition of the derivative. And what does it mean? Conceptually, you heard rate of change, there's another better word.
The slope.
The slope. And what's the second derivative?
The change of the slope.
Which is called the. That's one word. What?
She said acceleration.
The curvature. Remember that we haven't thought at all yet about what the function actually means. But if we take some function, okay, and I now ask you to find the minimum or the maximum, what am I looking
The curvature. Like sine convention.
for? Sure, yeah, so that would tell you something a little bit about whether it's concave up or concave down. But this is concave up and this is concave down, and the place where that switches is here, and that is not the minimum. So we want something similar but different.
Oh, the slope is 0.
The slope is 0. So we ask, where is the derivative equal to 0? And it's equal to here, here, here. Those are all 0 points of the derivative. And then we ask whether it's the max or the minimum, and we do that by asking about the sign of the slope.
The curvature.
The curvature. So the curvature will either be plus curvature or negative curvature. Right? First derivative gives you the slope, where the slope is 0. That tells you the min or the max, and then you can figure out whether you're at a min or a max based on the curvature of the function. Okay. There's a lot of other things in here that folks, I think a lot of these, they're just like, do you remember them? Like the famous one, what is the derivative of this function?
It's dx.
Yeah, that's okay. We all got that. Okay. That's the only one that you have to like for sure know. Okay. We're gonna use a lot of this different stuff And my hope is by the end of it, you'll be like, oh, I got all of this in my head. Line integrals, area integrals, they actually look like this. Right? And they tend to do something like this. Right? So it's an integral along a path. That'd be the line integral. An area integral would be an integral over an area. And we'll need to remember those because, for example, if you have some object, and we imagine fluid flowing through it, then you would want to integrate what flowed through it. Right? Okay. Partial derivatives. I think almost everyone got this one. It's okay. Partial derivative is their function is of x and y, then the partial derivative is only with respect to x, treating y as a constant. Okay. How is that different from a differential equation? Very importantly, there is no equal sign. Until there is an equal sign, it is not an equation. Okay, so if I have a differential function that looks like that, with an equal sign and something on the other side of the equal sign, that's an equation. So if I have a differential and an equal sign, it's a differential equation. Ta-da! What's the solution to this differential equation?
The partial derivative of the left side. The right side.
But what I've written is d dx of f is equal to f. What's that? It's correct. It's yes. Right? Because look, I just wrote it right there. And I set you up at it. Okay. Okay, so we'll get used to doing this type of stuff. We just want to have this in our back pocket. I know that it's like coming off a winter break, lots of stuff been going on. Got to shake the rust loose. And that way, when we jump into thinking about the mathematics, right, we're all on the same page. And so if there's something on here in particular that you were like, I didn't know what the fuck you were saying, that's perfectly okay. We can talk about them after, we can talk about them next class, whatever. Technically, I was supposed to give you homework. But this one's a fun one. Okay, so I'll post it today. You can look at it. If you don't love it, questions, comments, concerns? Work due?
Yeah.
Good question. What do you guys prefer? Wednesday? End of class Wednesday, so that you have the weekend and 2 class days to work on it? Or Friday, when I'm not here and I can't check if you've turned it in, and I'll check on Monday?
It's in person.
Or, yeah, ideally. What's gonna happen is you're gonna write down homework. You're gonna hand it to me. I'm gonna immediately look at it, mark it up, and give it right back to you. So the idea is that if I do this properly, you get feedback right away. If I do this improperly, I sit with a stack of homework that's like 6 weeks old, and you never learn anything about what that, right?
Know when the student health sessions are yet or no?
No, it's whatever you guys. It was gonna be in the welcoming survey, but I guess I didn't send that out to anyone. So, I'll try and set up like 4 different ones. I think I got feedback that 30 minutes wasn't enough. Maybe I'll set them for an hour. I don't know. Always rough because then no one comes and I'm like sitting there for an hour doing nothing. But cool. Other questions, comments, concerns? All right, I'll see some of you in like an hour and a half. Who else is taking computational? Oh, wow. Okay, cool.